Hey everyone, welcome to Soapsa's classes. Today we are going to solve mathematical economics question from Indian Economic Service General Paper 1. Yes, so in front of you is a question that is divided into three parts. So the first part is about the indirect utility function. So first you have been asked to define indirect utility function. So what is indirect utility function? So basically utility function means what? It shows the combination of two commodities. So basically demand of two commodities by a consumer which maximizes the utility of the consumer. Now indirect utility function means since the consumer that he is consuming X and Y is basically function of what? It is a function of price and income. So if instead of writing the equation or the function in terms of X and Y, we write it in terms of price and income, then we get indirect utility function. So using notation here, we know that the demand is what? It is a function of, let's say, P1, P2 and M, right? So that is price and income. And X2 is also the function of P1, P2, M. So this is the demand function we derive from utility function. Right? So if U is the direct utility function where X1, X2 is the demand function which is function of P1, P2, PM. So what can I write? I can write down our indirect utility function as first of all U is function of X1, X2. So in X, I'm going to write down its function that is X1, P1, P2 and M, comma, X2, P1, P2, M. So that means this utility function is directly the function of X1 and X2 and indirectly the function of price and income. So I can write down this is equivalent to this is my indirect utility function, right? So when I'm writing it in the as a function of prices and income, so that becomes my indirect utility function, which is obviously derived from the direct function. Why? Because X1 and X2 are the demand functions of these variables. So this is what our indirect utility function is. Now they have asked you to derive indirect utility function from the direct utility function. So since they have not given any specific utility function, so we will use our general form of utility function and budget line and see the technique of how to derive the indirect utility function. Okay. Now to begin with, let us assume the objective is to maximize utility, which is the function of X and Y. Okay, two commodities subject to the budget line, right? That is M is equals to Px into X plus Py into Y. So where all the notations have its usual meaning. Usual meaning means X and Y are the consumption of X and Y by the consumer. U is the utility derived from the consumption. M is the income or the budget of the consumer with which he will have to spend on X and Y, and the price of X is Px and the price of Y is Py. So this is the question. Okay, now this is our direct utility function. So from here I am going to derive the indirect utility functions. I'm going to do it using Lagrangian expression, right? So how can I write down the Lagrangian expression? It can be written as L is equals to, so we first of all we write down the objective function, so that is U X comma Y, and we join the constraint with this a single equation using the Lagrangian multiplier, that is, let's say, lambda. So plus lambda into m minus px into x plus py into y. So this becomes our Lagrangian equation, and lambda is our Lagrangian multiplier. So it actually connects the objective and the constraint equation. So we get our Lagrangian equation. So here our problem is to maximize. So that means we are going to find out the first order conditions here, right? So since there are 3 parameters, so I am going to have 3 first order conditions, right? So number 1 is delta L by delta X. Second one that I'm going to find out is delta L by delta Y. And then lastly, I am going to find it with respect to the lambda. Now this is equals to 0. So this is our first order or the necessary condition, right? Now I'm going to solve this. So there is, with respect to X, what are you going to get here? This is delta U by delta X minus lambda into Px. Others are constants at 0. This is equals to 0. So from here I can derive that lambda is equals to ux, that is delta u by delta x by px. So let us mark it as equation 1, right? Now again the Lagrangian equation we are going to differentiate with respect to y. So again delta u by delta y, so u y minus lambda into price of y, because others it will be 0. So this is the condition. So from here lambda is equals to this u y, that is delta u by delta y by py. And now this is my second equation. And when I'm going to differentiate it with respect to lambda, so the answer is m minus px into x plus py into y is equals to 0, or m is equals to px into x plus py into y. So this is third equation, and this is very much at the original budget line equation, right? So these are our first order conditions, okay? Now using these two conditions, that is condition 1 and condition 2, I'm going to compare these two and find out the relation between x and y. So comparing 1 and 2, we get or see, so this is our consumer's equilibrium condition, isn't it? So using Lagrange, the equilibrium condition can be derived by comparing the first two first order conditions of this. So this is our actually consumer's equilibrium condition. So after solving this, we are going to get, after solving this equation, after solving this particular equation, let's say 4, and putting x in third equation or the budget line, we will get x star, that is a demand, a Marshallian demand function of x. So that is going to be the function of price of x, comma price of y and income, and y star, that is y star is function of again px, py and m. So these are the Marshallian demand function, right? If I put these values here in the objective function, that is the utility here, so I will get the direct utility function. So if I put the values of x and y here, I am going to get the indirect utility function, right? How? So I have what now? So the utility function is a function of x comma y. So if I put the values, that is the function will become, u is a function of x star of px comma py comma m comma y star of px comma py comma m. So that is v, that is another name for the function of px comma py comma m, and this is our indirect utility function. right? So this is how you can derive an indirect utility function from direct utility function. Now, let's scroll up and check the part 2 question and try to solve it. So what is the part 2 question? The second question they have asked you is, consider the indirect utility function. So this is an indirect utility function. As you can see, this function is of variable what? M, P1 and P2. So M is the income, P1 and P2 are the prices of good 1 and good 2 respectively, and V is the indirect utility function. Now using this indirect utility function, you have to find out the demand function of X1 and X2. So again, for this there is a formula. So we are going to find out this using Roy's identity, right? So first let us know what is Roy's identity. So Roy's identity. So using Roy's identity, we can calculate the Marshallian demand function from the indirect utility function, and it is given as, say, X M, okay, that is Marshallian demand function, is equals to minus of delta V by delta Px by delta V by delta M, where Px is the price of commodity X and M is the income and V is the indirect utility function. That means this is the ratio of the partial derivative of indirect utility function with respect to price of the commodity and income. So if I am going to find out the demand function for X, so I am going to use the price of X or commodity 1. Similarly, if I am going to find out the demand function of Y or the second commodity, so I am going to use the price of the second commodity to find the partial derivative, and the next one is obviously with respect to income. So using these formula, I can find out the Marshallian demand function, that is using Roy's identity. So let us write down the indirect utility function given in the question and try to find out the answer, right? So the indirect utility function is V is equals to M square by 4 P1 by P2. So let's just quickly write down. So given V is equals to M square by 4 P1 into P2. So this is our indirect utility function that is given. And you have to calculate X1M and X2M. So let us first find out the for X1M, that is the demand function for the first good, right? So in order to find out, the first step is delta V by delta P1, right? That is equal to how much? Let's differentiate. So we have minus M square by 4 P1 square P2, right? And delta V by delta M is equals to 2M by 4 P1 into P2. That is M by 2 P1 into P2. We will also find out the derivative with respect to P2 so that we can just directly put the formulas in Roy's identity and calculate the demand function. So the third derivative that I need is delta V by delta P2, that is with respect to the price of second good. And that is minus M square by 4 P1 into P2 square. So now I have all the three derivatives that I need. Now in order to calculate the demand function of first good, I am going to use Roy's identity. So for first good, the formula for Roy's identity is minus delta V by delta P1 by delta V by delta M. Let's put the values. Yes, it is minus M square by 4 P1 square into P2. Divided by M by 2 P1 P2. Okay, let's simplify. So obviously minus minus means I don't have to write the minus again, so it's positive. Okay, so m square by 4 p1 square into p2 times 2 p1 p2 by m. So this is the simplification. Let's get cancelled. P2 p2 gets cancelled, p1 gets cancelled, this is also cancelled, and 2 ones are 2, 2 2s are 4. So m by 2 p1. So this is x1m, that is the Marshallian demand function of the first commodity. Similarly, for the second one, we are going to calculate x2m is equals to minus of delta v by delta p2 by delta v by delta m, which is equals to, let's put the values, minus m square by 4 p1 into p2 square divided by 2, divided by m by 2 p1 into p2. Let's simplify. So after simplification, we get x2m is equals to m square by 4 p1 p2 square into 2 p1 p2 by m. And after simplifying, we have the answer, that is m by 2 p2, right? So if we scroll up, demand function for the first good is m by 2 p1 and the demand function for the second good is m by 2 p2. So these are the answers for our second part of the question. Now let's again scroll back to find out the third part of the question, right? So here in the third part, you're given a utility function and budget function, and you have to find out the expenditure function of the consumer. So basically, the expenditure function of the consumer is the dual relation of what? The maximization of the utility. Okay, so here we have to do the cost minimization. So we have to write down the dual relation of the utility maximization problem. So how can I write it? Let's begin. So I have to write down as follows. So the objective now is to minimize the budget, right? So minimize px into x plus py into y. Okay, subject to the utility. So say now utility is constant, so x into y is equals to, say, u star. Okay, that is a constant utility. So this is my problem, and solving this I'm going to get the expenditure function. To start with, let's write down the Lagrangian equation again. Let us denote z is equals to, the objective function is px into x plus py into y plus let us use some other variable for the multiplier, let's say mu. Okay, and inside we have to write down u star minus x into y. So this is our Lagrangian equation. Now again we have to solve the first order conditions, that is FOCs. Number one FOC is what? Now I'm going to differentiate this Lagrangian equation with respect to x, y, and our third parameter mu. So first one is delta z by delta x, that is px plus mu into minus y, right? This is equals to 0 since this is the first order condition. Now solving this, we get mu is equals to px by y. Let's say this is equation 1. Second is delta z by delta y. Now here this is equals to, now I have to differentiate with respect to y. So that is py minus mu x, right? Yes. That is py minus of mu x is equals to 0. So mu is equals to py by x. Now this is second equation 2. And lastly, that is delta z by delta lambda is equals to, let's check again, let's go up and see, that is, if I differentiate it with respect to mu, I get u star minus xy is equals to 0, right? So that is here u star minus x into y is equals to 0, or xy is equals to u star. So there are three equations. Now compare 1 and 2. Px by y is equals to py by x, or x by y is equals to py by px, or x is equals to py by px into y. Okay, so this is the relation between x and y from the equilibrium that we have got. Let's say this is fourth equation. Now what I have to do is, in order to find out the expenditure function, I have to put these values in my budget equation, right? So after putting this value of x in the budget equation, right, before finding the answer with respect to the expenditure function, so first I have to put these values in the constraint. Constraint is what? That is my satisfaction level, like constant satisfaction level. So let us put the value of x with respect to y in u star. Okay, now that is equation 3. So putting value of x in equation 3, that is, what is our equation 3? Equation 3 is xy is equals to u star, or x into py by px. Sorry, we are putting the values of x, yes, so this should be y. Px by py into y times y is equals to u star. So from here we get that y square into py by px is equals to u star, or y square is equals to u star px by py, or y is equals to root over u star into px by py. Now what is this? This is our compensated demand function of y that we have got. Now by the same way, we are going to find out the demand function of x, and after we have got this x and y function with respect to price and utility, we will substitute it in the expenditure constraint, that is the budget constraint, and hence find the our expenditure function. Okay, so let's first calculate x. So we know that from fourth equation, x is equals to py by px into y. So now I have the value of y. So if I put the value of y in fourth equation, I will get x, right? Compensated demand function of x. So now substituting value of y in equation 4. That is, x is equals to, what is our equation for? X is equals to py by px into y. And let's put the value here. That is, we get x is equals to px by py into root over u star px by py. Okay, this is py by px, right? So this is py by px. Now let's simplify. What do we get? So if I simplify, I get root over u star py by px. Now this is the compensated demand function of x. So now I have both the compensated demand function for commodity x and y, right? So this is for y, right? And this one is for x. Now I am going to put this x and y value in order to find the expenditure function in the following equation. To find the expenditure function, substitute the value of compensated demand function of x and y in E is equals to px into x plus py into y, right? That is equals to px into root over of u star py by px plus py into root over of u star px by py. Let's simplify. So after simplification, here we have got root over u star py into px plus again root over u star py into px. That is E is equals to 2 into root over u star py into px. So this is our expenditure function, required expenditure function. So this is the derivation of expenditure function. I hope it's clear.